This is a quick recap of what we learned today on matrices. Okay, so how did we start? We first said we wanted to look at functions going from the set called the real line to the real line with the following properties. A, f of x plus y is equal to f of x plus f of y. And then B, f of any constant alpha times x is equal to alpha times f of x. And this has to hold for all alpha, all x, and all y. And when you have this two properties together define f is a linear function. Now, the question we tried to solve in the class was, what are all these linear functions? Well, we came upon the fact that this function f has to be of the form f of x is equal to c times x, which means f is just multiplication by some number c and c equal to f of 1. In fact, if c is equal to f of 1, then for any other x, f of x is equal to f of 1 times x is equal to x times f of 1 is equal to c times x. Now we move to the next step. We wanted to consider functions f that go from R2 to R2. Now there was some confusion whether R2 was R squared or not. So remember we said R2 is equal to R into R. It's called the set of ordered pairs of real numbers. So the very important word here is ordered. The order matters. So that means 2, 3, which is in this set, is not equal to 3, 2. So it's not just pairs of real number, because then the pair in 2, 3 is the same as the pair in 3, 2. But it's the ordered pair 2, 3. And for a moment remember, where is 2, 3 on the graph? Well, you go 2 here and then 3 here. Here is 2, 3. And how do you do 3, 2? You go 1, 2, 3 and then 1, 2. And here 3, 2. Very different numbers. So these are R2, just to explain what is R2. So we wanted to consider functions from R2 to R2. The next step is, when we did the one from the real line to the real line, we focused on f of 1. Why did we do this? Because if you take x a real number, then x is equal to x times 1. So f of x you can compute as x f of x times 1, which is equal to x times f of 1. So knowing f of 1, this is the multiplication sign, is knowing f of 1, you can know any f of x. So 1 generates all real numbers by multiplication. What does that mean? That means exactly this. Every number x is x times 1. What about in R2? What generates R2? For this, what we did, we took any old vector, let's call it AB, and that is going to be equal to A times 1 0 plus B times 0 1. So it's equal to A times, we'll call this vector E1, plus B times, we'll call this vector E2. So these vectors E1 and E2 generate R2. So once you know these vectors E1 and E2, E1 and E2 generate the entire R2. Now, once I know what this function does to E1 and what the function does to E2, let's suppose I know these two things. Then, for any other vector, A has to be a combination of E1 and E2. So, alpha E1 plus beta E2, right? And then therefore f of A has to be f of alpha E1 plus beta E2, which by the additive property of f will be f of alpha E1 plus f of beta E2, and then by the multiplicative property it will be alpha times f of E1 plus beta times f of E2. So I need to understand what is f of E1 and f of E2, and we are going to make an assumption. F of E1 we are going to say is equal to some other vector which is AB, and f of E2 is yet another vector which is CD. CD and apply it to E1, which is 1 0, what do you get? Well, A times 1 but C times 0 will give you 0, so you get A, and B times 1 but D times 0 gives you 0, so you get B. It checks out. And then similarly, if you take A, B, C, D and you multiply it by 0 1, you will get A times 0 0 but C times 1 gives you C, B times 0 0 but D times 1 gives you D, which checks out. And so we can represent F to be the same as the matrix A, B, C, D as a mapping or a function from R2 to R2. The rest of the stuff in class, the rest is in the book.